morning.
Good morning, sir.
Today we are going to be looking at the differentiation of inverse trigonometric functions. Then what we are going to be looking at the tan inverse of S. And we have talked about the sin inverse of S. We have talked about the cos inverse of S. Now this is the last one, which is the tan. We're going to be looking at the tan inverse of S. Now we are still going to be using the same principle we use in the sin inverse and the cos inverse. Now let's say y is equal to tan inverse of S, and we meant to understand that a raised to the power minus 1 meaning 1 all over a. Therefore we are going to say y is equal to 1 all over the tan of S. That means S we times this. I'm going to have S times 1, which is S over tan. Then cross multiply. You cross multiply. Turn this over 1. Tan times y is going to be what? Tan y is equal to 1 times S is what? S. I'm going to be using implicit to differentiate this. Implicit differentiation to differentiate this. That is, what is the differentiation of tan y? You are going to have sec square y with dy all over the s is equal to what is the differentiation of s, which is 1. Now we are looking for dy all over the s. You divide by sec square y divided by sec square y. This and this will cancel. We left with dy all over the s to be 1 all over sec square y. Now in our identity, trigonometry identities, we are having that 1 plus tan squared theta is equal to sec squared theta. This is one of our trigonometry identities. 1 plus tan squared theta is equal to sec squared theta. Therefore, since we are working with, sec squared theta is equal to 1 plus tan squared theta. We can remove the theta, then we replace it with y by saying sec square y is equal to 1 plus tan square y. Our y becomes the angles which we are dealing with. Now, we now put this into this. We cannot say dy ds is equal to 1 all over. Wherever you see sec square y, replace it with this. Then we are having 1 plus tan square y. Now we have gotten this. Now, let's say dy with respect to ds is equal to 1 all over 1 plus tan square y. Now, tan square y, our tan of y is what? Is s. Tan y is s. Wherever you see tan y, replace it with s. Then we are going to put s. And we are having s, our tan is twice here, that is square. This is going to have this. Therefore, dy with respect to the s is going to be 1 over, it's going to be 1 plus s squared to be our what? Final answer. That means 1 all over 1 plus s squared to be our final answer. Now when we find the inverse of tan inverse of s, we are going to be having 1 over 1 plus s squared. Thank you very much. See you in the next class.